In this video, we're going to talk about diffusion and effusion of gases. So, in our previous videos, we talked about kinetic molecular theory, and we said that, gases are colliding with each other. And that's because they are traveling very fast, and there's a lot of moles of gas in any room. Now, the average distance that a gas travels before colliding into something is called the mean free path. And we can actually calculate this. So N2 at room temperature only goes 93 nanometers before hitting something. To put that into perspective, if N2 was a golf ball, it would go 40 feet before it hit something. So it can go quite a far distance before colliding into another gas molecule. So here's just a thought experiment for you. Do you think mean free path increases or decreases with increased pressure? Do you have an answer? Well, mean free path should decrease with increased pressure because remember, pressure is force divided by area. If you have more force, you have more collisions. If you have more collisions, then the less time between collisions, so the less distance traveled. Now let's just go through the terms of diffusion and effusion. So diffusion is the random spread of molecules from high concentration to low concentration. And really, speed is dependent on the root mean squared velocity, what we talked about in a previous video. So heavier molecules are slower, so they diffuse slower. Lighter molecules are faster, they diffuse faster because it's random movement. Now, effusion, that's what happens where you have a gas escaping into a vacuum through a small hole. So that's what's shown here. We have a rectangle that's closed off in the center with a small hole. One side's a vacuum, one side's not. The gas molecules will go into this vacuum, and that's called effusion. And that's also related to root mean squared velocity. Heavier molecules have a lower velocity, so they're slower to go in, and so they effuse more slowly. Now, Graham's law of effusion tells us the effusion rate for two gases, because we just said that heavier molecules effuse slower. The rate's actually proportional to 1 divided by the square root of molar mass. And knowing that, this is where Graham's law of effusion comes in. For the rate of gas A, the effusion rate of gas A divided by the effusion rate of gas B equals the square root of the molar mass of B divided by the molar mass of A. So let's see if we can use this. We have a mixture of two gases. Gas 1 is helium, and we don't know what gas 2 is. Gas 1 has an effusion rate of 105 meters per second. Gas 2 has an effusion rate of 52.5 meters per second. So, what is the molecular weight of gas 2? Take a minute, try to solve that. Come back when you have an answer. Alright, let's take a look. So we're going to use Graham's law, where rate of A divided by B equals the square root of mass of B divided by mass of A. So rate of A is 105, mass of A is 4.003. Rate of B, 52.5, mass of B unknown. I'm going to divide these two numbers and I get 2. Now I want to get rid of the square root. And the way to get rid of a square root is to square each side. So I'm left with 4 equals MB divided by 4.003. MB is 16 when we account for sig figs. Therefore, our gas was oxygen, because oxygen has a weight of 16. Molecular oxygen, that is. And that's it for this video. And I'll see you in the next video.